Hi, this is Rishi and welcome to the YouTube channel Science with Rishi. Before we start our second video of the chapter 2, let me tell you something. Whatever be the topic and whatever be the subject, you must have a clear idea of the basics. Okay? It must be on the basics that you have to work out maximum. If you have your basics clear, if you are very thorough with the concept, all the advanced portions that will come automatically to your brain. You can understand everything very easily. The most important thing is always the foundation or the basics. Okay, keep that in your mind always wherever you are and whichever topic you are studying. Now, in the last class we saw the conversion of theta into radians, right? I have told you 360 degree is equal to 2 pi radians, which means 1 degree is 2 pi by 360 radians, and 1 minute is 1 degree by 60, which is equal to 2 pi by 360 into 1 by 60 radian, and 1 second is 1 minute by 60, which is equal to 2 pi by 360 into 1 by 60 into 60 radians. In the last video I just missed out this 360 part, so just change it in your notebook. This is the actual conversion method, and this is your example 2.1. okay, now let's continue with the usual method. Measurement of distances. We all know the SI unit of distance is meters, yes, but using a meter scale, what is the range of distance that you can measure? Okay, you can measure 1 centimeter, you can measure up to 1 millimeter, and if you put a meter scale 1000 times, you can measure 1 kilometer. And what about the distances beyond 1 kilometer and beyond this 1 millimeter? For that we have to use certain other techniques, right? Okay, let us discuss some techniques like that. First, measurement of large distances. Before that, let us know what is parallax. Okay, what is parallax? You have a pen in your hand, right? Just hold that pen straight. You just close one of your eyes. Now you open that eye and close the other eye. Now, although you didn't change your hand, change the position of your hand, you might have seen that the position of the pen has got shifted, right? This phenomenon is called parallax phenomenon. Okay, and the distance or the shift in that position is actually the distance between your eyes. Okay, so we are using the same principle here to find out large distances. For example, let us see how to measure the distance from the earth to the sun. Okay, so let these 2 points A and B are 2 cities on the earth, and the distance between these 2 points, we know it, and let it be small b. Okay, so these two are 2 cities and the distance between these 2 cities is b, and let this be the sun. Okay, now we are just joining these 2 lines. Okay, now compared to the distance between this city to this city to the sun, or from B to the sun, the distance between A and B is very small, right? So let this be D. B is very small compared to D, right? So in this case, we can assume that the distance from A to the Sun and from B to the Sun are same, right? So let this one also be D. Now, in this case, in this situation, we can assume that AB is the length of an arc of a circle with its diameter D and the center S, right? AB is the length of the arc of a circle with its diameter D and the center is S. Okay, now let's take the plane angle. Okay, let this be angle phi. So what is phi? B by D, right? So what is D? B by this angle phi, and angle phi is in radian. We know how to convert theta into radians. This is the method of finding out this D. And what is D? D is the distance from Earth to the Sun. So this is how the distance from Earth to the Sun is calculated. Now another example, how to find out the radius or diameter of the Sun. Okay, let 2 points X and Y. These 2 points are located diametrically opposite to the Sun. Okay, so let this be your Sun. If X is here, Y is here. So that means the distance between X and Y is the diameter of your Sun. Okay, so this is the value that we have to find out, this X, Y. Now you have a basic here, the same city A. This is actually called a basis. Okay, in the last portion we had two bases, A and B. Here we are taking only one point. Okay, now let me join these 2 points. Now from city A, you are using your telescope to view at this point X, and with the same telescope you are viewing at this point Y. Okay, now you can measure this angle theta, right? And we know the distance between Earth and the Sun, which we have found out just before. Let it be that same D. So using that same plane angle method, theta in radius is equal to, in radian is equal to xy by D, right? And xy is equal to theta into D. Yes, we have found out the diameter of our Sun. Hope you have understood how the measurement of large distances are taken. Now the next topic, measurement of small distances. To see certain things which we cannot see using our naked eye, what is the instrument that we are using? Yes, microscope. And what is the medium that we are using to see those objects? Is the visible light or the sunlight, right? The wavelength of our visible light is 4000 angstrom to 7000 angstrom. 1 angstrom is 10 to the power minus 10. So you can say 4 into 10 to the power of minus 7 meters to 7 into 10 to the power of minus 7 meters. Okay. Now imagine you have to observe a nucleus through a microscope. Okay, and the size of that nucleus is 10 to the power minus 8, or let it be an atom, whatever it is. The important thing is that its size is minus 10 to the power of minus 8 meters, Now my question is, can you use visible light to observe this one? My answer is no. See, the range of the wavelength of visible light is in the order of 10 to the power minus 7, but the size of that atom is 10 to the power minus 8, which means the size of the atom is smaller than the wavelength of this light, by which light cannot scatter this one. Okay, so what is the other possibility? You have to find some other medium instead of the visible light which has got a wavelength lesser than this 10 to the power of minus 8, in the order of 10 to the power of minus 10 or something, to see this atom. Okay, for that we can use electron microscope. Electron microscope. Why? Because in electron microscope, instead of visible light, they are using a beam of electrons. They are sending electrons onto that atom or that molecule, whatever it is, and that is used to observe this one. And can you imagine what is the wavelength of these electrons? It is around 0.6 angstrom or 0.6 into 10 to the power of minus 10 meters, which is obviously smaller than the size of this atom. So this is the general rule. The wavelength should be smaller than the size of the particle if you want to observe that particle. Okay, keep this thing in your mind. Now in your text there has been given an example of how to find the size of a molecule of oleic acid. Okay, now let me explain it how it is done. We have to take 1 centimeter cube of this oleic acid. Okay, now we have to mix 19 centimeter cube of alcohol in it, by which we will get a solution of 20 centimeter cube, right? So in a solution of 20 centimeter cube, we have 1 centimeter cube of oleic acid, right? So in 1 centimeter cube of this solution, how much oleic acid we will be having? Okay, in 20 centimeter cube solution, we have 1 centimeter cube of acid. So in 1 centimeter cube of solution, yes, we will be having 1 by 20 centimeter cube of acid, right? So we are taking 1 centimeter cube of this solution and we are taking 1 centimeter cube of this solution and we are putting another 19 centimeter cube of alcohol in it. So again we have got 20 centimeter cube, but here the strength of the acid is less, right? So how much will be in 1 centimeter cube of this second solution? We will be having 1 by 20 into 20 of oleic acid, right? This much centimeter cube, right? Is this much clear? Now what do we have? We have a solution which has got in 1 centimeter cube of solution contain 1 by 400 centimeter cube of oleic acid, right? Let's keep it aside. Now you take a beaker, pour water into it and put a powder, and the name of that powder is lycopodium. Okay, The name of that powder is lycopodium powder. And you have put some amount of that powder in that beaker which has got water. Now you take 1 drop of this solution, okay, and you know the volume of that 1 drop, okay. Now how much oleic acid will that drop contain? In 1 centimeter cube we have 1 by 400 centimeter cube of acid. So in V centimeter cube, how much we will be having? We have V into 1 by 400, right? Centimeter cube of acid. Okay, so we put 1 drop which has got V by 400 centimeter cube of acid in it into that water which already contained this lycopodium powder. Now what will happen is that just like oil will float on the top of water, this acid will also form a circular film, okay. Now we can measure the diameter of that circular film and hence we can find out its area, right? So let A be the area of that film, okay. Now what is thickness? Thickness is volume divided by area. Now what is the volume? If V is the volume of 1 drop, V by 400 is the volume of the acid, this much centimeter cube, right, divided by area, A centimeter square, that is thickness is V by 400 A centimeter. This is the method to find out small distances. Hope this is clear. Now moving on to the next topic, measurement of mass. So what is the SI unit of mass? It's kilogram, right? It's kilogram. In our day-to-day life, what is the range of the mass that we are dealing with? From milligram to maximum kilogram, and very rarely we go up to 1000 kilogram, right? But always kilogram is not a convenient unit. When it comes to the weight of certain atoms and molecules, we are not expressing it in kilogram, right? So for that, our scientists have come with another unit called AMU. AMU stands for atomic mass unit, okay, and 1 AMU is mass of 1 C12 atom divided by 12, okay. This is 1 AMU, and AMU is the unit we are using when it comes to the mass of these small atoms, small particles like atoms, molecules, nucleus, etc. Here also we have methods to find out large and small masses. Large masses means the mass of a planet, of a sun, etc. For that we are using gravitation method, which we will be studying in some other chapter, don't worry. And to find out small distances, there is a method called mass spectrography. The principle of that method is the radius of the trajectory. Trajectory means path, simply the path, okay. The radius of the path followed by a charged particle in a uniform electric and magnetic field, okay, it is proportional to its mass, okay. The radius of the trajectory followed by a charged particle in a uniform electric and magnetic field is proportional to its mass. Just keep it in your mind, that's it. So that's what you have to study in this topic, measurement of mass. Now measurement of time. Here, let's do an interesting experiment. Okay, you have two clocks, two ordinary clocks which we use in our living room, bedroom, kitchen, etc. Clock A and clock B. You have set the time of both to exactly 12 o'clock. Okay, and you started operating them. So both these clocks are now running. Okay, now after few months, say around 2, 3, 4 months, you can see a small difference in the time of these two. Suppose if this clock is showing 12 o'clock, this clock at the same time may be showing some value like 11:59:57. That is, there is a error of around 3 seconds, or it might be showing something like this also. It has gone up some 5 seconds. So what does that mean? There is an error between the readings of clock A and clock B, right? Now imagine we have a clock, and we are depending on that clock to maintain the time of that entire nation. Can we afford to have such an error for that clock? No, certainly not. So for that, in India, we are using cesium atomic clocks. Okay, cesium atomic clocks. They are very, very accurate. Okay, the error in the time of these clocks is just 32 microseconds in 1 year. Micro means 10 to the power of minus 6. So there is an error of only 32 microseconds in 1 year, which is absolutely fine. Okay, so this is the only portion that has to be taught in this particular topic. The rest of the parts you can just easily read and understand. That's it for the second video. Before stopping, let's have a quick recap on what all things we have discussed so far. We have studied how to measure large distances, the distance between sun and earth, the diameter of the sun. These two methods, how they are calculated we have discussed. Measurement of small distances, why we cannot use the ordinary microscope to view a small atom or a nucleus, why we have to use this electron microscope, and how to find out the thickness of a molecule of an oleic acid. Then measurement of mass, what is AMU, we have mentioned what is the use of gravitation and mass spectrography, and last, measurement of time, what is the importance of cesium atomic clock. Hope you have understood all these things. I hope you are preparing in your home also. So see you for the next video. Until then, Rishi signing off. Bye, take care, Jai Hind.